So I am going to finish the review that we started on Tuesday. I apologize for not being able to make it today. I think I did a lot more on Tuesday and Wednesday than I should have. And so I need to just kind of relax today. So we have 16 more problems to go. I will tell you that on this test, there are no chapter 11 questions. So don't worry about that. But there will be chapter 11 questions on the final exam. So do be prepared for that. So on problem number 20, you can combine like radicals. So that would end up being 4 square roots of 10. I cannot break down the square root of 10 in any way, shape, or form because there are no perfect square factors of 10 other than 1. So that's all I can do with that particular problem. For number 21 and number 22, and even number 23 for adding and subtracting, it looks like I can't add a square root of 20 and a square root of 45, but square root of 20 and square root of 45 can be broken down. So square root of 20 can be broken down into 4 times 5, which becomes 2 square roots of 5. So I end up with 2 square roots of 5 for the square root of 20. And then when I break up, remember you do have that negative 4 out in front, so keep that in mind. When I break up 45, that breaks up, and I think I told you the trick. If this is a square root of 5, divide 45 by 5, which is 9, and 9 ends up being a perfect square. So I end up with negative 4 times 3 times the square root of 5, because I can pull out the 3 when I take the square root of 9. So that is negative 12 square roots of 5. And when you add that together, grand total, you get negative 10 square roots of 5. The square root of 5 does not change, but the coefficients of each radical will. Okay, so for number 22, same thing. Square root of 18 breaks down into 9 times 2, which would be 3 square roots of 2. So I end up with 3 square roots of 2 in the place of square root 19. 2 goes into 98 49 times. So I have positive 3 square roots of 49 times 2. That would be positive 3 times 7 square roots of 2, which is plus 21 square roots of 2. So I'm going to add 3 square roots of 2 to 21 square roots of 2, and that gives me 24 square roots of 2 as a final answer. Now, in number 23, we actually have to do that, but we have to do that with variables as well. So when I take the first part, which is 6x times the square root of 80x to the third, I'm going to break down 80 into 16 times 5. And I'm going to break down my x to the third to x squared and x to the first. That way, this exponent is bigger than the index, so I know something's going to come out. So for just this part alone, I have 6x times 4. 2 divided by 2 is x to the first. And then I have 5x left behind. So all together, that becomes 24x squared times the square root of 5x. Now, I'm going to use that trick to break down my negative square root of 20. I don't have enough room over here, so I'm going to do it kind of right here in the middle. So 5 goes into 24 times, so that's 4 times 5. And then I'm going to break up that 5 into x to the 4th times x to the 1st. I can take the square root of 4, which is 2. This exponent 4 divided by the index gives me x squared. And if you notice, I end up with a 5x, which is exactly under the radical, which is exactly what I got the first time. Now, I have to be careful here because I have to make sure that I can combine those two terms together. So 24x squared minus 2x squared gives me 22x x squared, square roots of 5x. And that would be my final answer for number 23. 24, I'm going to multiply these together. That gives me square root of 64, which is just flat out 8. I don't have to simplify those first. I can multiply them straight across and then deal with what's left. I'm going to do the same thing for number 25. That would be the square root of 35c squared. And the only thing that I can break down is the c squared. So I end up with c times the square root of 35. There are no factors of 35 that is a perfect square other than 1. So this would be my final answer for number 25. Number 26, when I multiply it all together, I get 50c to the third. I'm going to break that up into 25 times 2. And then I'm going to take my exponent because it's bigger than my index, and I'm going to split it to c squared times c. So a 5 comes out, c comes out, and the 2c gets left behind. And that would be my final answer for number 26. Number 27 and 28. 27 is for or distributing, and 28 is foiling. So for number 27, I have square root 42. And then I have 2 square roots of 12, so plus 2 square roots of 12. And then I have to ask myself, are there any factors of 42 that are perfect squares? And there are not. And then I have to ask myself if there are any perfect square factors of 12, which there are. You've got 4 times 3. And so this ends up being square root of 42. You cannot do anything with that. Plus 2 times 2, square roots of 3, because the square root of 4 is 2. So my final answer would be square root 42 plus 4 square roots of 3. You cannot add those together because they are not like radicals. So when you go to do number 28, I am going to FOIL both of these problems. So 2 root x times 2 root x gives me 4x. We talked about a square root of x times a square root of x is just x. So that's what I did. 2 root x minus or times root 5 is negative 2 root 5x. Then I have positive 2 root 5x, which will cancel. And then I have minus 5. So my outcome for the top part is 4x minus 5. That is my final answer. These are conjugates, 1 plus, 1 minus. So the O and the I term should always cancel. Now, the second part, they are not conjugates. So we are going to multiply these together. And the 2 in the middle should be exactly the same. And what I mean by that, if both of these terms will be exactly the same, so we can combine them into a bigger term. So root x times root x is just x. Root x times root 5 is root 5x. I get a second positive root 5x. And then at the end, I get a positive 5. So when I add this together, I get x plus 2 root 5x plus 5. And that would be my answer. It's not pretty, but that would be my final answer. For number 29, 72 divided by 2, because I can think about that as, can I reduce 72 by 2? That reduces nice and pretty to 36, which is just 6. Now, not all radicals are going to reduce that way. And in a few minutes, we're going to have another problem that looks like that. But we can't divide 72 by the denominator or whatever. So we'll see that in just a minute. In this particular problem, I do not have a radical in the bottom. So all it is asking me to do here is reduce. 3 goes into 3 once. It goes into negative 8 -6 times, and it goes into 21 7 times. So I get -6 plus 1 root 5 all over +7. You have to reduce 1, 2, 3 values, or you reduce none of them. It's all or nothing. And those 3 values are the values that are no longer under radicals. Now in this problem, I do have a radical in the denominator, so I do need to take care of that. So I'm going to multiply the top and the bottom by the conjugate of the denominator. So that would be 5 plus 2 root 2. Let me make that look more like a 2 than a z. So across the top, I'm going to distribute, and on the bottom, I'm going to FOIL, and since they are conjugates, those two middle terms should cancel. So -7 times 5 is -35, and -7 times 2 is -14. Bring along the square root of 2. I can't multiply the 2 on the inside by 7 because this -7 is not under a radical. So the denominator becomes 25 plus 10 root 2. The next term I get is -10 root 2. And I told you the O and the I cancel, and so they will cancel. And then the last thing I get is -2 times 2, -2 times, I'm sorry, -4, because 2 times 2. When I do -2 root 2 times 2 root 2, that gives me -4 times 2, which is -8. These cancel. 25 minus 8 is, I believe, 17. So -35 minus 14 square roots of 2 all over 17 would be my answer. Now, I do have to check. 35, 14, and 17 do not reduce. You have to check them all or reduce none of them. And so that would be my final answer. For number 32, we are solving the equation. So we isolate the square root, then we square both sides. And we cancel the square and the square root cancel. So that leads me to x equals to 81. Now, when I check it, square root of 81 is 9. So that would be my answer. You always have to check because you want u to be a real number and you want whatever u is to, or x is, to make sure that this number, whatever it is not negative once you clean that up. Now, for number 33, I need to isolate my radical by adding 2 to both sides. So that gives me square root u minus 7 equals to 6. At that point, I'm going to square both sides. And that gives me u minus 7 equals to 36. And when I add 7, that gives me u equals to 43. Now, when I check it, -2 plus the square root of 43 minus 7 equals to 4. Minus 2 plus the square root of 36 equals to, I'm sorry, that's not 30. That's 42. I apologize, not 43. I apologize. That should be 42. And that's -2 plus 6, which is indeed 4. So my answer of 42 is that is my answer because it did work when I substituted it back in. So for number 34, we can go straight to squaring both sides. My square root cancels. That gives me u plus 12 equals to 64. 8 times 8 is 64. When I subtract that, I get 52. When I check my answer, 52 plus 12 should equal to 8. That's square root 64, which does equal to 8. So I keep that answer. If you plug in an answer and at any point you end up with a negative number right here, when it says all numbers have to be real, you would say no real solution. Number 35, this flat out tells you to write in terms of I. So the first thing I'm going to do is I'm going to take out the imaginary unit, because this actually splits into square root -1 times square root of positive 96. The square root of -1 is always an I. Now I have to break down the square root of 96, which I believe is 16 times 6. So that would give me 4I square roots of 6 as a final answer, because that would be 4 square roots of 6, and you have to remember to multiply it by the I. And then the last question, you cannot deal with any negative radicals. So the first thing you need to do is I square roots of 2 times I square roots of 8. Multiply that together, that gives you I square roots of 16. We talked about I square equaling to -1, so I'm going to replace that with -1, and I'm going to take the square root. So my final answer for the top part is -4. For the second part, I have to take I square roots of 48 over square root of 6. I can reduce this. 6 goes into 48, and I can do that because they're both under radicals. So that's I square roots of 8. Then I'm going to break down the square root of 8 to 4 times 2. And that gives me 2I square roots of 2 as a final answer for the second part. I cannot do anything as long as those numbers are under the radical are negative. So please make sure that you do take those imaginary units out and use your imaginary units, like I square equals -1, and the other one is the square root of -1 equals 2I. Those are the two main imaginary units that you should be familiar with. Okay, so I hope this helps, and I apologize again for not being able to join y'all today. So good luck with your test. If you have any questions, please feel free to reach out to me, and maybe we can jump on a Teams meeting and answer any of your questions.